Have you ever wondered what really happens when something falls into a black hole? Imagine yourself floating in space, staring into that abyss where physics, time, and space stop working as you know them. From where you are, everything seems relatively calm. But just ahead, the universe begins to go insane. And that's no exaggeration. Literally, the laws of physics collapse inside. It's like every rule you ever learned starts breaking down, one by one, until only chaos remains. The gravity of a black hole isn't just strong, it's absurd. It doesn't just pull you in, it distorts the very fabric of reality. And the craziest part? If you were falling into one right now, you wouldn't even notice the exact moment you cross the point of no return. The so-called event horizon. That's the critical line. Once you've crossed it, there's no going back. But even then, from your perspective, everything would feel normal. The illusion is cruel. To you, everything feels normal. You keep falling, the gravity gets more intense, but there's no dramatic warning. Meanwhile, I'm out here watching, and to me, it looks like you never truly crossed over. I'd see you frozen, getting slower, redder, until you vanish, as if your light was being stretched, pulled, until it fades out. That's gravitational redshift, just one of the many bizarre distortions happening around black holes. But hang on, that's not even the start of what really goes down, because now you've crossed the event horizon. And in here, it's a whole different story. In here, there's no turning back. Space becomes time, time becomes space, and the direction you're heading is inevitable. Imagine space as a river flowing into the black hole. At the edge, the current is strong. At the event horizon, it flows at the speed of light. And inside, it flows faster than anything can swim against, even light. You're caught in a current of space-time, pulled deeper and deeper. No return, no control, no escape. The direction of that river is now your final destination. All you can do is go with the flow. And then comes the most uncomfortable part. You start to feel something. Because gravity is getting stronger at one part of your body than another. The technical term for this is spaghettification. Yeah, it sounds like a joke, but it's real. It's what physics predicts. That's right, spaghettification. Your body starts stretching, not just outward, but at a fundamental level. The difference in gravitational force between your head and your feet is so extreme that your body begins to elongate. And not just that, you also get squeezed from the sides, stretched and compressed at the same time. Like space itself is trying to turn you into a single, infinitely thin line. And the closer you get to the singularity, the center of the black hole, the more extreme the effects become. First, your body disappears as we know it. Then, your atoms break apart. Then, protons break into quarks. Eventually, everything you were ceases to exist in any recognizable form. You become a soup of fundamental particles, a whisper of what used to be. But it's not just you. It's everything that falls into a black hole. Stars, planets, light, all of it gets pulled apart. The singularity doesn't discriminate. Everything that crosses the line gets stripped to the core. Like a black hole is a machine that shreds reality. Now, pay attention to this. The singularity isn't just a point in space. It's also a point in time. The end of time, actually, because inside a black hole, space and time get mixed together. And for anything that falls in, reaching the singularity is as unavoidable as reaching tomorrow. In there, time doesn't move forward step by step. It's a sentence. That's right. Escaping the singularity is like trying to escape the future. You can't. There's nowhere to run, no way to stop. Time in there always pulls you forward. It's your final destination. Every second pushes you toward it like a never-ending avalanche. And the singularity just waits. Now you might be thinking, okay, all this stuff falls into the black hole, but then what? What happens to all that matter? Does it just vanish? Seems like it, right? But that creates a massive problem for physics, a paradox. And this might be the most important question in modern physics. Because according to the laws of nature, information can't be destroyed, ever. It can get scrambled, spread out, hidden, but it never disappears. Even if it seems impossible, it has to exist somewhere. That's the rule. And rules like that can't be broken. Enter Stephen Hawking. He showed that black holes aren't completely black after all. They emit something, a radiation, appropriately called Hawking radiation. A faint glow, invisible to the eye, but with massive consequences. It's a weak radiation, almost undetectable, But with one very important detail, it causes the black hole to lose energy. Slowly, very slowly, but it loses it. And that loss over time leads to its death. A black hole can completely evaporate, disappear. That means black holes one day fade away. They vanish. They cease to exist. And here comes the dilemma. If the black hole disappears, where did all that information go? If it vanished too, then we've got a serious issue. A fundamental violation of the laws of nature. This was the great contradiction for decades, because Hawking's original version said the radiation was totally random. It carried no trace of what fell inside. But that breaks one of the most fundamental laws of physics, and that drove physicists crazy for decades. Years of heated debates, nearly impossible calculations, and increasingly wild theories. Then, in 2019, a possible answer came along. Some scientists published studies suggesting that maybe Hawking had missed a tiny, crucial detail, a subtle twist that changes everything. They proposed that the radiation isn't entirely random, that it does carry information, just in an incredibly subtle and scrambled way. Like each piece of radiation holds a tiny fragment of what once fell into the black hole, a nearly impossible puzzle to solve, but not totally impossible. But how? How can information trapped at the end of time escape? That's the question, still echoing through modern science. And the answers are bold. One of the most mind-blowing theories, and yes, it's being seriously considered, is that the inside and outside of a black hole are somehow connected. Like there's a shortcut, a tunnel, a bridge, a wormhole, a hidden path through the universe. In this view, the information that seemed to vanish never really went anywhere. It's always been here, just in a different form. Scattered in the radiation that escapes, like you after being spaghettified, had your essential information sent back into the universe. Not as a body, not as consciousness, but as code. As an energy signature that never really dies. But hey, that's just one theory. There are others. Some say the inside of a black hole never really existed. Others suggest the entire universe can be described as a giant quantum computer where everything is information and nothing has a fixed location. Like reality is a program and black holes are system errors. Sounds like madness, right? Maybe it is. But what these studies show is that understanding black holes isn't just about dead stars. It's about understanding the deepest layers of reality. It's about understanding time, space, and even you. Because at the core, we're all made of the same cosmic stuff. What happens in there reflects something about what's happening out here. And the wildest part, the more we learn, the more we realize how much we still don't know. Every answer unlocks 10 new questions, and every black hole is an invitation to dive deeper into the unknown. So next time you look up at the night sky, especially toward the center of our galaxy, remember there's a black hole out there, silent, invisible, but hiding secrets that could change everything we think we know about the universe, and maybe about ourselves. If this made your curiosity tingle, mission accomplished. Like the video, subscribe to the channel, and if you want to keep exploring the cosmos, click on the next video right here. There's still so much more waiting for us. Together. Until next time, and don't forget to look up tonight, because the more you understand the universe, the more magical it becomes.